Hi everybody, this is Algebra 2, Lesson 66. In this lesson we're going to cover signs of fractions and 30, 60, and 90-degree triangles. Okay, so we'll just go straight into the first example. It's important to note before we start this example that when we have a fraction with negatives and positives, there's three places we can put the negatives and the positives. So let's say we have 3/4. We could put a negative here, we could put a negative here, or we could put a negative here. So there's three locations, okay? If we can only move a negative from one spot to another. So if we have this negative 3/4, if we want to turn that positive, we can make that be negative, or we can make the bottom be negative. It does not make the top and the bottom be negative. Those are negative over negative, makes a positive. All right, so on this one, if we want to get rid of this negative in the middle and make that be a positive, then we can do negative times this whole bottom part, right? Make that negative, so that would make positive there and negative there. Right? Hope that made sense to everybody. All right, so if I'm going to turn this positive, right, then that means I'm going to multiply this whole bottom times a negative. Negative times negative right there, I would get a positive x. Negative times a positive would be a -3. Now I have like terms on the bottom. So this would equal 1 over x minus 3 plus 7a over x minus 3. And that's going to be 1 plus 7a over x minus 3. Here's the answer to that one. It's a pretty easy concept, actually. All right, so this one. All right, so this one, if we rewrote this with our x at the beginning, we would have negative x plus 3. Okay, so we need to be able to recognize that. This one says x minus 3. This one's negative x plus 3. Okay, to fix that, we can get rid of this negative by changing this to a negative. So if I change that to a negative, then I can multiply this by a negative, which would make that be positive and that be negative. So I'll have x minus 3, okay? All right, so now I'm going to have 4x plus 5 over x minus 3 minus 2x minus 3 over x minus 3. So our bottoms are like terms. All right, so now I've got 4x minus 2. So if I want to get rid of this minus and make this be adding, I could change it there, and that would make that be negative and that be positive. Okay, so I'm just moving that negative around. All right, so this would be 4 minus 2, which would be 2x, and then 5 plus 3 would be 8 over x minus 3. All right, so just remember there are three places where your negative can be, and you can move them around. All right, the next part's about triangles. Right triangles whose acute angles are 30 degrees and 60 degrees are encountered often in physics and engineering. These triangles are often called 30, 60, 90 triangles because the other angle is 90 there. These triangles are all similar to this triangle. Okay, and if we forget, so we've got this one right here is going to be 1, the hypotenuse is 2, and then your up and down is the square root of 3. To see how we got this, if we had a triangle that was all equal, right, this is 60, 60, 60, right, and that means each of these sides would be, and let's say that each of those sides are 2. If we wanted to divide that in half, we're going to get our 20, 60, 30 right there, right? Because we divided the 60 in half, and now we've got a 30-degree angle right there. Okay. That means that this part will be 1, and a squared plus b squared equals c squared. That makes this part be the square root of 3. All right, so we're going to use that to try to figure out triangles. It's easy if you just remember 1, 2, 3, your hypotenuse is in the middle. All right, so for this one, it says use similar triangles to find out x and y. So I'm just going to say 1, 2, square root of 3. That's the easiest way to do it. You could draw another triangle, right, and put your 1, 2, square root of 3 right there. Now we need to figure out the scale factor. So we have 5, and we're going to say our 5 is related to 2. So 2 times our scale factor equals 5. If we're going from small to large, right? From this triangle to this triangle. All right, so our scale factor is 5 over 2. So if we're down here on the bottom and we want y, we're going to say basically the same thing. We would say y times our scale factor equals 1. All right. Our scale factor is 5 over 2. Let's clear that out. So we're going to say 1 times our scale factor, which is 5 over 2, equals y. So y would equal 5 over 2. All right, now we've got our square root of 3. So let's see, the square root of 3 times our scale factor, which is 5 over 2, equals x. Okay, so that one, we're just going to say 5, yeah, that's easy. X equals 5 times the square root of 3 over 2. We just basically put those together. Square root of 3 times that would be 5 times square root of 3 over 2. So that's how you find those. Just come up with your scale factor. All right, I think there's another one. Nope. All right, go ahead and pause the video and work those practice problems, and I'll come back and work them for you. All right, so hopefully you pause that video and work these practice problems. And now I'm going to work them for you. Let's start with this one. So I need to change that by changing its sign. So if I change that to a positive, that means I can change that to a positive and that to a negative. So I'm going to have 1 over z minus 2 plus 3m over z minus 2. And I'm going to get 1 plus 3m over z minus 2. And that's the correct answer for that one. That one was pretty easy. All right, next one. This one, we've got this guy we want to get rid of. So if we turn all of this top negative, then we can turn that positive. So if I did a negative there, then that would make this positive and this positive, right? The whole bottom. And then if I did that, I could make all of these negative in there. All right, so now I have like terms on the bottom, x plus 4 and x plus 4. This would be negative 3x minus 7, and this would be x minus 7. All right, so negative 3, positive 1 would be negative 2x, and then negative 7 would be negative 14 over x plus 4. You could also write that whole thing as like we could get rid of this negative right here, and we could put it there. So we could say negative 2x plus 14 over x minus 4. Hang on, I didn't do that right. This is the whole equation's negative. The whole term is negative. There we go. All right, so those are the two answers you could have gotten, one of those two. Both those are two are right. So either the whole top's negative or the whole term's negative. That's a plus. Okay, and that is the answer to B. All right, and now our similar triangles. Now when we look at this, we got to make sure that we know this one's A is 1, B is, let's see, our hypotenuse goes in the middle, B's are 2, and then this one's going to be our square root of 3. So we're going to say 7 times our scale factor equals the square root of 3. No, let's go the other way. Okay, so we're going to start with our 1, 2, 3. So square root of 3 times the scale factor equals 7. All right, that way we can use this. Square root of 3 divided by square root of 3. Those cancel. Our scale factor equals 7 over the square root of 3. Now, we don't want to leave this radical on the bottom, so we're going to do times square root of 3 on both. And we're going to get 7 times square root of 3 over 3. Square root of 3 times square root of 3 would be 3. All right, so that's our scale factor. If we're going from starting with our 1, 2, 3, ending with our number. All right, so A will be our 1. So that means 1 times our scale factor equals A. Okay, so 1 times 7 times square root of 3 over 3 equals A. And yeah, 1 times that is just that. So A is the scale factor. So whatever your 1 side is always just going to be whatever your scale factor is, because you just multiply times 1. So there's A. All right, B would be 2. All right, so we're going to say 2, B equals 2 times our scale factor, which, okay, so B equals 7 times the square root of 3 over 3 times 2. That's 2 over 1. So that would be 7 times 2 is 14 times the square root of 3 over 3. And so that is B. Those are also pretty easy. All right, that is it for the practice problems on this lesson. Thanks for watching.